So, hello and welcome to a new lecture on statistics. The scope of today's lecture is to introduce the concept of binomial distribution. And we saw in previous lectures that a distribution is basically a function that describes how many times a certain outcome is obtained in a random experiment on average. And we saw that the idea of or asking for the number of times that a certain outcome is going to be obtained on average in a random experiment is closely linked to the question of what is the probability that this outcome is going to take place in a random experiment. So today we are going to discuss the binomial distribution, and the binomial distribution is a very special distribution again, in the sense that it only knows success or no success. So the random experiments that we can actually analyze, they may have very different outcomes, but we are going to classify them into success and no success. And a very typical example of a binomial, of a random experiment that can be used to introduce the binomial distribution is the one of the flip of a coin that we already discussed in previous lectures. And if you assume that the coin is fair, so you basically have a 50-50% chance to obtain heads and tails, then the binomial distribution will also have a very symmetric shape. So in general, what you would actually expect is when you flip a coin, let's say 10 times, that on average, in general, you will obtain 5 times heads and 5 times tails, because the coin is fair and both results are equally likely to be obtained. So if you would actually repeat this random experiment of flipping the coin 10 times and the whole experiment 1,000,000 times, you would actually see on average that the outcome is like 50-50, so 5 times heads and 5 times tails. Of course, you would actually also have situations where you would obtain basically only 1 time tails and 9 times heads, or the other way around, 9 times heads and 1 time tails. But on average, you would actually realize that the outcome will be 50-50. So let's have a deeper look into this random experiment of the flip of a coin and have a look of how the distribution would graphically actually look like. So basically, as we saw in previous lectures, distribution can be represented on a 2-dimensional plot where you basically have a y-axis and an x-axis. And on the x-axis, we are going to introduce the random variables x. And on the y-axis, we are going to introduce their corresponding probabilities. So in this particular case, we will actually look at the random experiment where we flip a coin 10 times in a row. So you would write that the random variable will follow a binomial law with the number of times that you actually repeat the random experiment, which in this kind is 10. I will first write it generically, so n, and the probability that your success is going to be obtained. So this time tails. So let's call this probability p for the moment, just to have it general. And the associated probability law for the binomial distribution would actually be something that looks like this. So basically you have the probability of a certain random variable to be k. So basically that means that you would actually expect to have k time success. And it is called a binomial distribution because the first term in the probability law is actually the binomial coefficient. So you take k combinations out of n, and you multiply it by the number of successes that you will obtain, probability of successes, so p to the power k, times the probability of no success, so 1 minus p. So for 1 being the total probability minus the probability of success, and you basically repeat the experiment n times, so you have it n minus k, because you expect k times the probability of success. And this term here, the binomial coefficient, basically tells us or provides us the different combinations of obtaining success. So you can basically, let's say k is 3, then you can flip the coin 10 times and then have success like tails just already at the first flip. and then have heads, 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 and then again tails, and then again sometimes heads, and then tails at the end, for instance. Or you can have like 3 times tails in a row and then only have no success afterwards. So this term here contains all the different combinations that will occur when you suppose that you will actually have a random experiment where you have a k-time success. So that's the general formula for a binomial distribution. And let's come back now to the example of flipping a fair coin. So basically you have the random variables here and you flip it 10 times. So you start somewhere at random variable 0, and then you have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So what you would basically expect is that the fairest coin again, suppose that the fairest coin, you have 50-50% chance, that on average the probability is highest for 5 times tails. So here you put somewhere the probabilities, and you would actually then expect that your probability is somewhere here for having or obtaining 5 times tails. And then, as I said, in the case of a fair coin, you have a symmetric distribution. So you would expect that on average you have for obtaining 4 times tails, 4 times success, or 6 times tails, 6 times success, the same probability. So you have symmetric distribution around its maximum value, 5. And then again for x equals 3 and x equals 7. It's again symmetric. Then x equals 2 and x equals 8. Again symmetric. And then you're somewhere here for x equals 1 and x equals 9. And then a very low probability of obtaining 0 times. So it's, from a logical point of view, I mean, if you do the experiment 10 times, it's very unlikely to obtain 0 times tails. You will at least, on average, obtain a couple of times tails. And obtaining 10 times tails in a row is also very unlikely. So you have a very small probability here. So what you can actually do, for instance, you can put in here the formula, p of x equals 5. So you have 5 times success. You repeat the experiment 10 times with 5 times success. Of course, you have a probability that is 1/2 because 50-50% chance to obtain tails. So basically you have 1/2 to the power 5 this time because k is 5. That you multiply by 1 minus 1/2 to the power 10 minus 5. And basically this here is the combination, the binomial coefficients, which basically tells us how you can actually obtain, what are all the combinations to obtain 5 times success when you flip a coin 10 times. So it's the factorial of 10 divided by 5 factorial, 10 minus 5 factorial. Here you basically have 1/2. And here you obtain 1/2 as well. So what you actually get is 1/2 to the power 5 times 1/2 to the power 5. And if you work out this result, which is not very difficult, you would obtain something like, let's say, what was it again? Approximately 0.247, I think. So 2.7, yeah, 4.6, sorry. And you can actually repeat the same game and work out the probability for x equals 4. And then on average you get something like I think 0.205. And as the probability distribution is symmetric, you would actually also get for probability of x equals 6, something that is approximately 0.205. So we can introduce this here and have here at this level, so maximum value for the probability, we have 0.246. And then at this level here, for x equals 4 and x equals 6, which we actually computed here, or which is easily computed if you do the math, and then you obtain 0.205. So you see that for a binomial distribution that has, in a random experiment, that it is, for instance, the flip of a coin, and we suppose that you have a fair coin, the distribution is symmetric. So what you can also imagine is that you don't have a fair coin, but you have a coin where you, in general, obtain only with 30% chance tails and with 70% chance hats. So it's not fair anymore, and then you basically would have something that would look actually differently, and we are going to sketch this. And here again you can easily do the math, but what I'm going to do here is to provide you the graph. So again you have the random variable x here, and here you have the associated probabilities. And again you flip the coin 10 times, so you have to put on the random variable values here. 9 and 10. So this time we say, so here we say probability of success is 1/2 equals 0.5, and probability of no success, which is sometimes called Q, is 1 minus P. So this is the 1 minus P that we have here, which in this time is also 1/2 or 0.5. You could actually repeat the same game, and so you suppose that your coin this time is not fair, and then you could assume that your probability of success would be actually something that is, let's say P equals 3/10, which is 0.3, and probability of no success is 1 minus 3/10, which is 7/10, or 0.7. And so then you would expect to obtain tails, which is the success, to have a peak not on average, not around 5, but rather with a 30% chance around 3. So you flip the coin 10 times. So so your success is highest for the random variable tree. So let's go to draw this. Let's say highest success is somewhere here. And then you basically have something like this. And this time it's not symmetric anymore. So you see, your peak is here, and the curve is actually not symmetric anymore, but it is shifted to the left for tails values, success values around the around the random variable x equals 3. And you can actually do the very similar calculations. Let's do them here for this particular case. So basically what you have, you still use this formula, which is the binomial formula, of course. So let's say, for instance, the peak is at x equals 3. So you would basically obtain, you still repeat the random experiment 10 times, but this time number of success is 3. And contrary to the previous example, we don't have a probability p, which is 1/2, but 3/10. 3/10 to the power k, or in this time 3, times 1 minus 3/10, and this time not to the power 10 minus 5, but to the power 10 10 minus 3. And if you do the math here again, you would actually obtain something where you have 10 factorial divided by 3 factorial, 10 minus 3 factorial. And this time you basically have 3 times to the power 3 multiplied by, this is 10 tenths, so 7 tenths, 7 by the power, 3, 7 by the power 7, and here you have 10 to the power 10. So you can easily work this out, and you will actually find the value here that corresponds to this. This can be easily done. You can also write a computer program that runs all the different results from 0 to 10, but you can do it also by hand. So that's it basically on binomial distributions, where we looked at the random experiment of a flip of a coin, which is a very typical one. If you need additional clarifications or explanations, please leave a message in the comment section below. If you like more content like this, then please give my video a thumbs up and subscribe to my channel, and see you in the next video.